So before we get ready with our calculus, we should have a little refreshment for our previous concepts that we learned through our pre-algebra and algebra education. So for now, let's start with brushing or refurbishing the fractions concepts in our minds. So first, you need to remember that you can't divide by 0. So the denominator of a fraction can never equal to 0. So if you say 0 over 5 equal 0 in this case, but 5 over 0 is undefined. So you can't divide by 0. That's what it is. So for multiplying fractions, that's an easy topic. As you can see in the equation over here, you have a over b multiplied by c over d. This equals ac over bd. So if you have 2 over 5 multiplied by 3 over 4, that equals 2 by 3 equals 6 over 5 by 4, 20. You can simplify it by dividing over 2. 6 over 2 is 3, 20 over 2 is 10. So if you have two fractions that are divided on each other, so you have 3 over 10 divided by 4 over 5. In this case, it's easier for us to flip the other half of the equation and change that equation into fractions multiplications. So if here there's a, so for 4 there's a and there's b, so a over b and c over d. So in this case, if they are divided, you can say c over d multiplied by b over a. So you just only moved the denominator in each other. So this way you can do a multiplication. So if you have 3 over 10 multiplied by 5 over 4, instead of 3 over 10 divided by 4 over 5. So we switch those two. So 3 by 5 is 15 over 10 by 4 is 40. If you have two fractions that are being in addition or subtraction, the same rules apply. So a over c plus b over c. So we have a common denominator in here. So you can say a plus b over c. But if the denominator is different, then that's a different story. So in this case, 2 over 7 plus 3 over 7, that equals 2 plus 3 over 7, that's 5 over 7. Now, if you have a over e plus b over c, what you're gonna do? This way you do cross multiplication, so that equals a multiplied by c plus b multiplied by e over e multiplied by c. So that's the way you do it in case you need it. Now if we want to visit the powers, so x to the power of 0 equals 1. X to the power of minus 3, that can be represented as 1 over x to the power of 3. If you want the equation, here it is. X to the power of minus a equals 1 over x to the power of a. If you have x to the power of 2 over 3, that means the cubic root of x squared. That's what it is. And you can imagine in a different way, x to the power of 1 over 3 multiplied by 2, that's x to the power 2 over 3. So here we can see the equation, x to the power of a over b equals the b root of x to the power of a equals b root of x to the power of a. You can represent in a different way. So x to the power of 2 over 3 equals, so the cubic root of x can be represented as x to the power of 1 over 3. That's squared. So multiplying from the outside, that's the 2 multiplied by 1 over 3rd, that's x to the power of 2 over 3. That's just a more simpler way of representing that. So x squared multiplied by x cubed, in this case we say x to the power of 5, so you can keep the x here, and you add the powers. So x to the power of 5. The equation saying x to the power of a multiplied by x to the power of b, that's x to the power of a plus b. You are adding the powers. X to the power of 5 over x to the power of 3, that's equal x squared. In this case, if you go to the equation, x to the power of a over x to the power of b, that's x to the power of a minus b. So when you flip the b up here, you change the plus sign into minus. So that's x to the power of a minus b. I'm sure you know these. We're just refreshing your minds about them to make sure you are ready to get into the calculus. So x to the power of 2 multiplied by power of 3, in this case x to the power of 6. So if you have x in this representation, x to the power of a, between parentheses, all to the power of b, that's x to the power of a multiplied by b. It's not plus b, it's multiplied by b. If you have x, y, z to the power of 3 all multiplied, then you can distribute the power on each variable in this case. So it is x cubed, y cubed, z cubed, and so on. And this is the equation for it, just for your memory. If you have x over y to the power of 4, so you have multiplication or division, you can easily distribute the power over the variables. But that can't happen when you have plus or minus sign. Like if you're adding or subtracting, that's a different story. So x over y to the power of a equals x to the power of a over y to the power of a. So as we said, addition and subtraction is different story. So if you have x plus y to the power of 2, you can't say it is equal x squared plus y squared. That's a complete root, have a different equation. The equation is right here. So if you have x plus 2 squared, this means x plus 2 multiplied by x plus 2. If you do the distributed multiplication in here, then that will give you x squared plus xy plus xy plus y squared. That's equals x squared plus 2xy plus y squared. Just pay attention to that. If we want to revisit the logarithms, log c of 1 equals 0, log c of c equal 1. If you have log c of ab, you can distribute the log, in this case, log c of a plus log c of b. If you have a division, log c of a over b, that's log c of a minus log c of b. Log c of a to the power b, the b can go in here, then you have b log c to the power of a. Log a, the b, equals log c the b over log c the a. Quickly, let's revisit the solving of quadratic equations. We have three methods that we gonna revisit. Either you have factoring or quadratic formula, or you have completing square. So for factoring, you have this equation, 2x squared minus 5x equals 12. Now you bring all the terms to the left hand side of the equation, make sure the equation equals 0. So we have 2x squared minus 5x minus 12, so we change the plus sign to minus because we move it to the left side of the equal sign. Whenever you move it right or left, you need to change the sign. Now the factors are, we are saying that 2x squared minus 5x minus 12 is an outcome of multiplying the two factors, 2x plus 3 by x minus 4. In this case, you take each one of them on the side and find the solution of the variable. So 2x plus 3 here, we said move the 3 to the other side of the equation. You have 2x equal minus 3. We change the sign of the 3. In this way, the solution equals x equal minus 3 over 2. Then you have the other factor, which is x minus 4. Move 4 to the next side of the equation and change the sign from minus 4 to plus 4. X equal 4. So the solution of this equation is either x equal minus 3 over 2 or x equal 4. Moving to the next method, if we have a quadratic formula, then if we have an equation in this form, ax squared plus bx plus c equals 0, then we can use the quadratic formula to find the solution of the equation. In this case, the values of x equal minus b, which is the factor of x, or x to the power of 1, plus or minus the square root of b squared minus 4ac. So the a is the factor of x squared and c is the constant in the equation, over 2a. A is the same thing, the factor of x squared. If we want to have an example for that, the same example that we had previously, 2x squared minus 5x minus 12 equals 0. Now you plug the coefficients in the equation. So you can say the 2, so the a in this case equals 2. A equals 2. And minus 5 represents the b. So minus 5 represents the b. And minus 12 represents the c. Don't forget and say 12, it's minus 12. Okay, so if you plug in the coefficients for x, one time plus, one time minus, so this plus or minus, one time we use it as a plus, one time as a minus to get the factor. So in this case we have 5 plus or minus 11 over 4. That's either 16 over 4 or minus 6 over 4. So x equal 4 or minus 3 over 2. That's the solution for your equation using the quadratic formula. If you have the method of completing the squares, having this equation 3x squared equal 24x plus 27. We put everything related to x and x squared to the left hand side of the equation and keep the constant on the right hand of the equation in this case. So you divide both sides on the coefficient of x. So you have x squared here having a factor of 3. So you divide over 3 for everybody. So you have x squared minus 8x, which is minus 24 over 3, equals 27 over 3, which is 9. Now you take half of the coefficient of x and you square it, then you add that to both sides. So in this case, half of minus 8, so coefficient of x minus 8, is minus 4. It's minus 8 over 2, that's minus 4. Then the square of minus 4 is 16. So you add 16 to both sides of the equation on the left and on the right. So we add 16 here, we add 16 here. Now you have factor the left side into a binomial squared. Then this will give you x minus 4 squared equal 25. And your final solution, x equal either 9 or minus 1. The second part that we want to visit as a part of our refreshment and preparation for calculus is the functions graph. We want to make sure that we understand the most common or famous functions, how they are drawn or how do they look like at the xy axis. As you can see in here, we have the xy coordinate system as known as the Cartesian, referred to René Descartes, who came up with this xy axis representation for functions. So we have the x-axis on the horizontal in here, and we have the y-axis on the vertical. And remember that we have 4 quadrants for the Cartesian. We have the first quadrant and the second quadrant in here, third quadrant in this area, and the fourth quadrant in this area. Then if you have a point on the Cartesian, then you represent it through a point represented by x and y. So in this case, x is 8, y is 3. In this way you are declaring a point on the Cartesian or the xy coordinate system. For the common functions, if you go to a function that's saying it is y equal 3x plus 5, as you remember, you use the needed equations to find the points where this function is crossing the y-axis and where's the points that this function is crossing the x-axis, and you connect between those, and this line would represent this equation on the Cartesian. If you have y equal x squared minus 2, same thing, you see where this function is crossing on the x-axis and y-axis, having 3 points. In this case, we know that this is a quadratic equation. If you have y equal the absolute value of x, then this is how it look like. As you remember, y equals sine of x, it will be a sinusoidal form, as you can see here. if you have an equation that's representing a circle, in this case x squared plus y squared equal 9, then you represent the 9 with this dotted line in here, and x squared plus y squared equals 0. That's a full circle with origin on the axis, or the origin of the axis, the point 0 and 0. If you have a more complicated function, x equal y cubed minus 5y squared plus 10, then that's how it happened to have the function to look like. Now for inversed functions, if you have a function of x equal x squared, then this is how his graph is looking like. And y equal x, this is how the graph is looking like. F inverse of x equal the square root of x, this is how the graph is looking like. For logarithmics, if you have f of x equal 2 to the power of x, that can be written in the logarithmic form g of x, or you can say f of x, same thing, equal the logarithmic of 2 of x, in this case, can be written in this way. Now, having the horizontal transformation, some functions with changing some values, you'll have horizontal transformation means the function will move along the x-axis, or vertical transformation, that means the function, same graph, same shape, but it moves on the y-axis. So here we have y equal 2 to x to the power of x plus 3. So since you say y equal 2 to the power of x plus 3, then in this case, this is how the graph is looking like. Now, if you multiply the value of x with numbers, or you add or subtract some numbers to the x, then you are having horizontal transformation on the x-axis. So you can see here y equal 2 to the power of x, here y equal 2 to the power of x minus 3, and so on. So you are transforming on the y-axis either to the right or to the left based on the values you're adding or removing from the equation, as a multiplication to the value of x, subtraction, addition, or division. Again, another horizontal transformation, you have y equal 2 to the power of minus x, and you have y equal 2 to the power of x, so the exact opposite for the value of x. So we have plus x in the power here, we have minus x in the power here. In this way, both of them are passing through the same point on the y-axis, but they are forming the same shape, but in a mirror kind of feature. So that's a really quick visit for the functions and how they look like, just to make sure we are sharpening your memory and bringing back some nostalgia for you, and hopefully we can bring back more of your memories of the other topics that we need to know as we are moving towards starting to learn about calculus. Trigonometry. We learned in high school how to solve a right triangle trigonometry properties, and we learned what's the opposite, what's the adjacent, and what's the hypo. Now we're going to revisit that topic and make sure you guys are on the same page and ready to jump into calculus and solve any trigonometry problem that may face you while you're applying the new concepts that you learn from calculus. Let's jump into our presentation. So this is a right triangle with an angle of 90 degrees. Usually, you remember in your high school, you used to look for the sine and cosine and the tan for angle x in here, and you defined in the past the string or the hypo, and you defined this branch as the adjacent part of the triangle, and you define this part as the opposite. In this case, the opposite is giving it a letter of O, adjacent letter of A, and the hypo is a letter of H. And for the sake of showing you the concepts and reviewing with you what you learned in high schools, we give the opposite a value of 3, we give the adjacent a value of 4, we give the hypo a value of 5. So, as you remember, if we used to say what is the sine of the angle x, or what is the sine of x for short, that's the opposite over the hypo. In this case, 3 over 5. Cosine of x is the adjacent adjacent to x, over the hypo. The tan is the opposite over the adjacent, in this case 3/4. Then we learned how to find the secant of x and the cosecant of x and the cotan of x. Cosecant of x is the hypo over the opposite, which is vice versa of the sine of x, which is the opposite over the hypo. And the secant is the hypo over the adjacent, which is the invert of cosine of x. Cosine of x used to be a, the adjacent, over the hypo. And tan and cotan are inverted as well. So that make life easier for you if you want to remember sine, cosine, and tan, but I don't advise you at all to remember. Math is not about memorizing. Now, having advancement with the internet and all the information are online, you can pull up those data as soon as you want or as fast as your typing speed. But you need to know what is the concept behind it. What do you mean by sine of x is opposite over hypo, or cosine of x is adjacent over hypo? So don't save anything in your mind. That's what I advise you. Everything is online, everything is in books, and it's easy to be accessed, but understand the concept behind it. That's what matters. Now we have two special right triangles. Right triangle mean a triangle with an angle of 90 degrees. The first type, we have the 90 degrees here, and we have the other two angles of the triangle are 45 and 45. If you remember from your mid-school or high school, the total number or the sum of the angles of a right triangle, or any triangle basically, should be 180 degrees. In this case, you have 90 degrees here, you have 45 here and 45 here. The other case, you could have a 90 degrees here, and you have a 60 degrees on this angle and 30 degrees on this angle. Now, how does the sine, cosine, tan, cotan, cosecant, and secant look like for those triangles? For the 45 degrees right triangle, the sine of the angle 45 degrees is the opposite over the hypo. So if we are talking about this angle, the opposite is 1, the hypo is the square root of 2, which equals 0.71. Cosine the 45, if we're talking about this, it's the adjacent over the hypo, which is the same as the sine. The tan is the opposite over the adjacent, which is 1/1 equals 1. Cosecant, secant, cotan, etc. If you have a right triangle with angles of 60 degrees and 30 degrees for the rest of the triangles, for the rest of the angles, then you have sine of 30, in this case, the opposite, which is 1 over the hypo, which is 2, that gives you a half. Cosine the 30 is the adjacent over the hypo, that's the square root of 3 over 2. Tan of 30 is opposite over adjacent, which is 1 over the square root of 3. The sine of 60 degrees, in this case, opposite over hypo, the opposite is square root of 3 over 2, and the adjacent in this case is the 1. So you see what's going on? The angle of 30, that's the adjacent to the angle of 30. When you jump to the angle of 60, what's the adjacent of 60? The hypo is common, it doesn't change based on the angle, it's common for the whole triangle, but the adjacent relative to the angle 60 is 1 in this case, while the adjacent for the angle 30 is square root of 3. If you got that, then all of these mean nothing, they're easy. And finally, the identities. As you can see, mathematics found her identity. Did you find your identity? That's important to answer at this point. Well, all jokes aside, identities, you don't need to save anything in your mind. I mean, if you save it in your mind, make your life easier, maybe the hand operated solution will be faster for you instead of going back always to references. But again, it's math, man. You don't save anything in your mind. As long as you understand what's going on, then you don't need to save anything in your mind. So here it is. I combined the most famous identities for you so that you can go back to them whenever you need them as we're moving forward with our calculus. And by now, I think we are ready to jump into our calculus, starting with our limits.